Hi, my name is Paweł Spechalski and today I will answer 3 questions. Question number 1 is how flight controller outputs are working. I know that most of you really don't want or need to know, but I want to answer this unspoken question and in a layman's terms explain in which details the servo output and motor output is slightly different and why it has to be handled in a slightly different way. Then I will answer the question why cannot I map this pin on the flight controller to act as a servo or something else, or motor here or motor there, etc, etc. This is more or less why on some targets, on some boards, you cannot have any servos in case of multi-rotor configuration. And the question number 3 is why INAV does not have resource mapping. This will be rather highly technical, so if you don't want to listen to that stuff, here's the short version. Answer to the question number 1 is those pins, those outputs are driven by timers. And if timer is configured to any frequency, all the outputs connected to this timer has to have the same frequency. This brings us to the question number 2. And this is the reason why you cannot put any function to any pin, because, for example, if you have even the slowest ESC, it's driven by, let's say, 400 Hz, and the servo driven at 50 Hz, they cannot share the same timer. If timer is used for motor, it cannot be anymore used for servo. There are conflicts, and not every pin can be used with any timer. There are only specific possible configurations. And this also brings us to question number 3. We did not try to port resource mapping from the Betaflight to INAV because it's not solving all the problems that INAV users will meet, because we are using a lot of servos. INAV is used on airplanes, and unfortunately the solution from Betaflight, while great, fantastic, outstanding, is not preventing from fucking something up and smoking your servers because you did not know what you were doing. This is why we did not found a good solution that's easy to implement. So sorry. And now there will be a technical part with me drawing things on paper. Enjoy. So, motor output and also a servo output, not counting D-shot, is driven by something called the PWM. It's pulse width modulation. If we have an axis, here we have time, here we have voltage. So, pulse width 0, something goes up, something goes down, and like this, like this, like this, like this. This, for example, between one rising edge and the second rising edge, it's the frequency of the PWM. For motors, it's at least 400 Hz. For 400 Hz. It's for servos, it's usually 50 Hz. If we are using something like one shot 125, then the frequency goes up to how much? 250, so it's to more or less 4 kilohertz. Multi-shot is around 8 kilohertz. Never mind. This is a signal that a servo or the motor, the ESC, has to receive to be able to interpret what we are wanting to do with it and to act correctly. How it's done? Let's say we have a pin on the CPU connected to something, and here we have something called timer. Timer drives the output of the pin. If, for example, I will configure the timer to 50 Hz, let's say like this, then it will try to put the high value every, how much? 50 Hz is... damn, I forgot how to count simple things. 1000 plus slash 50 every, oh yeah, obvious. So 50 hertz is 20 milliseconds. So timer every 20 milliseconds will put the value up, and then after a configured, the length of this here will put the value down. So if I configure this to, let's say, 50 hertz, so 20 milliseconds to between putting the value down up, and then I will put the second value of, for example, 2 milliseconds after it was put up to put it down, I will have a beautiful 100% servo throw. If I want to have a servo throw of 0% with the pulse width of 1000 milliseconds, instead of 2 milliseconds, I only have to configure to this 1000 milliseconds equals 1 milliseconds. Simple, right? Almost exactly the same thing is happening for motors. Only instead of 50 hertz over here, we're gonna have a 400 hertz. So the volume, the value of the voltage will go up every 400 times per second, and 1000, I really should like 1000 every 2.5 milliseconds it will be put up. And to, for example, to have zero throttle on the motor, we have to configure this period of time still to 100 microseconds or 2000 microseconds if you want to have full throttle. Simple, right? So we only have to assign the timer to a pin and configure timer. Then our program can do completely different things. Do not worry about the PWM output on the pin, and it should be working fine. Right? It is. But the problems begins with timers. First of all, there is a limited number of timers. Let's say the number of timers, I don't remember how much exactly, let's say below 20. Below 20, and not only that, the timers also cannot be used as we want them. Because, for example, if we have a pin PA1, then let me open the specification. I don't think you want to show it. Want to see it. If we have PA1, pin PA1, for example, on the S1 and S1 output, then I can use timer 2 channel 2 or timer 5 channel 2 or that's all. This is all the usable timers I have for S1. If I have S2, for example, as PA2, because manufacturer connected pin PA2 of the CPU to the S2 output, then in case of PA2, I have timer 2 channel 3, timer 5 channel 3, and timer 9 channel 1. What does it mean? If I will use in both cases timer 2, then both of those pins can only work with the same frequency. Oh, there are channels, because timers are also, not all, but some timers are divided into channels. The timer still has to have the same frequency, but then using the channel you can decide how fast the value will go down on the timer. It simplifies. You can have multiple pins running the same timer as long as the channels on the timers are different. Okay, so, and then if we take a look at PA3 pin, for example, then it can be timer 2, what? Channel 4 or timer 5 channel 4 or timer 9 channel 2, or that is more or less all. There are only a limited number of configurations. Then, what to do next? Now, let's take a look at some of the code and on the examples of some of the flight controllers and see why not everything is just possible over there. Ready? Go! First, let's take a look how, for example, one of the best flight controllers, SP-Racing F4, is designed internally. This is a table that defines which output, in this case PWM1 to 8, are connected to different pins. So PWM1 is connected to pin PA6, PWM2 is connected to PA7. PA6, PA7, let's go back to my table. So PA6, PA7, multiple different implementations, 6, 7, you can more or less do whatever you want with them. And here for the PA6 we have timer 16 allocated, and to PA7 timer 17. So that means that motor 1, servo, no, the pin 1 and pin 2 can be configured however you want. You can, if you really want to, you can assign this to a motor, this to a servo, everything will be fine. But PWMs 3 to 6, 3, 4, 5, 6 are connected to PA11, 12, PB8, PB9, and all of those pins are connected to one timer, timer 4. So that means no matter what you want to do, PWM 3 to 6 on this board will be always running the same, exactly the same frequency. So you cannot allocate PWM3 to a servo and PWM4 to a motor, because you will either fry your motor or fry your servo, or this will just not work. Then, if we take a look at PWM7, this is PA2 and connected to timer 15, and the PWM8, PA3, also timer 15. So those two outputs are independent from previous outputs, but are dependent on each other and cannot be configured to different ROMs. So let's take a look now at the assign functions. In case of multi-rotors, this column here, all the outputs are used as motors because there will be no conflicts. But in case of two last pins, PWM7 and PWM8, it is possible to use those two outputs as servo outputs with completely different frequency than previous one. For example, for servo gimbal or what else, channel forwarding or whatever there is. This is why, even if you, for example, have a quadcopter and you are using only 4 first motors, motor 5 and 6 have to stay unused because they are sharing the same timer and frequency, the ones that before them, and only PWM 7 or 8 can be used as a servo in case of a multi-rotor. In case of flying wing scenario, it's different because pin 1 and 2 goes to motors, and everything else will be always configured as servos, absolutely no problems. But even if you would like to, you cannot assign motor to PWM6 because you will fry your ESC or something like that. Like I said, SP-Racing F3 is one of the best. So let's take a look at something else. For example, Omnibus F4 and motors. What we have here. Motor 1 and motor 2 are using timer 3, so they always have to have the same frequency. Then motor 3 and motor 4 are using completely different timers, so they can be configured as servos. But still, in case of multi-rotor, usually need 4 motors, so they are taken. Then we have what we have here, motor 5, which can be used as either motor on the multicopter or servo as a multicopter, but only if you are using quadcopter, or as a servo in case of airplane. And the last one, motor 6, which can be used as, for example, motor or multicopter servo, or fixed wing servo. This Omnibus F4 is still quite good design if we are talking about these things. Let's take a look now at something I like, but I'm kind of disappointed, and this thing is Matek F722. It's really fine, great for multicopters and flying fixed wings. I have to learn this fixed wings, but it's not as versatile as, for example, SP Racing, because if you will take a look at mappings and how the timers are used, and remembering that you cannot use S7 because it's not driven out directly, then there is almost no possibility to use a servo in case of multicopter configuration. What a bummer. Okay, I hope I did not lost you somewhere in the middle of this longish and slightly less structured than I hoped video. Anyhow, to sum things up. It's hardware. Sometimes there is something we can do, sometimes there is something we cannot do. There is only a limited number of hardware connections inside of the CPU that allows to use different pins and assign them different functions. Yeah, resource mapping is cool, but currently it's not solving all the problems that we will have. That's why there is no resource mapping in INAV yet. It's not that we don't want to, but we are afraid if we start to do something about it, we'll be doing only this for like a year or so, fixing the problems, targets, and so on and so on and so on and so on. Plus, please bear in mind that probably none of the INAV developers has all the boards that we are supposed to like maintain, because never mind. Anyhow, thumbs up if you liked it, please subscribe, and until the next one. Ciao!